Good morning. Uh, so today you guys are just going to work on wrapping up chapter 9 and learning new material there. Um, we're just it's just going to be a refresher on everything that we kind of covered in this chapter. Get you guys ready for whatever um, math class you have next year. So um, we're going to be wrapping up any new material. This is the new, probably the end of new material for this month. So or for this year. After this, we're going to be doing a bunch of review on stuff. So um, anyway, today's assignment is in on page 557. It's for the next 2 days. 557, 1 through 16, 23 through 25, and 32 through 33. So I'm just going to give you some example problems that are like those, and you can use those to do the problems in the book. So on problems 1 through 4 in the book, it says evaluate the expression, and what they're giving you is square root problems. So when they ask you to evaluate an expression and they're not asking you to solve for a variable, what you typically give is the prime root, okay? Because there's usually two answers to a square root, all right? Positive and negative version. In this case, though, we usually just give the positive or primary root. So square root of 9, you just have to ask yourself, what times itself gives you 9? And the answer to that question is 3, right? 3 times 3 gives you 9. So the square root of 9 is 3. What about the negative square root of 81? Well, underneath the square root is 81. What times itself gives you 81? And the answer is 9. But since there's a negative out front, it's like saying negative 1 times the square root of 81. So our answer is a negative 9. Okay. Um, and then on problems 5 through 12, those are actually solving for a variable. Okay, so on 5 through 12, it is when we're solving for a variable using square roots, and this is a quadratic equation. It is ax squared plus bx plus c, but what you can notice here is that the middle term bx is missing. In other words, in this case, uh, b is actually equal to 0 because 0 times x would be 0. So um, all we have is the ax squared, right? 5x squared, and c, which is negative 125. Um, but we don't want to use a quadratic formula here because it's actually easier to use square roots. And the way we do that is we move the 125 over to the other side, and we get 5x squared equals 125, and divide each side by 5, and I get x squared equals 25. So what I did there was I got the x all by itself, right? And I did that. I got the x by itself, or the x squared by itself, so that I can take the square root of both sides. What you do to one side, you have to do to the other. Right? So that gives me x equals, and this is where we don't just give the primary root, we give um, the positive and negative version, because in reality, what multiplied by itself gives me 25? The answer to that question is positive 5 and negative 5. So x is equal to plus or minus 5. Okay, that's your answer. All right, and then also in this chapter, we learned how to take the square root of fractions. And there's a couple of different ways you could do that type of work. We could simplify the fraction first and then break it up into the square root of the numerator over the square root of the denominator. Or we can go ahead right away and break it up into the square root of the numerator or the square root of the denominator. It's really up to you. I like to simplify first. If I can, the square root of 121 over 99, I know that 121 and 99 both have a common factor of 11. So what I'm going to do is say, hey, this is the square root of 11 over 9, right? Because 121 divided by 11 is 11, and 99 divided by 11 is 9. So I can then break this up into the square root of 11 over the square root of 9. And the square root of 9 is easy. So this is square root of 11 over 3. Now, remember to ask yourself when you're simplifying something, are there any factors under the square root symbol, any factors of that number that are perfect squares? And 11, there are no factors that are perfect squares. So square root of 11 is simplified as far as it'll get. And the square root of 9, of course, is 3, so that part is done. This is the simplified version of square root of 121 over 99. All right, square root of 81 over 7. There is no, I can't reduce that any, the 81 over 7. So I'm just going to go ahead and make this the square root of 81 over the square root of 7. That becomes, square root of 81 is 9 over square root of 7. Now, I cannot leave a square root in the denominator down below. I cannot leave that below in a fraction. So we have to do something to get rid of the square root of 7. What we do is called rationalizing the denominator. Okay? I have to multiply that by the square root of 7. And what we do down below in a fraction, we have to do up above as well, right? I'm just really, square root of 7 over square root of 7 is 1. I'm multiplying this by 1. Okay? So what happens? Square root of 7 times square root of 7, well, let me put the top together here. 9, the top becomes 9 square root of 7. The bottom becomes square root of 7 times the square root of 7 is the square root of 49. Which is, square root of 49 is just 7. Okay. All right, and then in the section where you're doing problems number 23 through 25, that's when you get into using the quadratic formula, right? This is ax squared plus bx plus c, that's equal to 0. So quadratic formula, you should have that memorized. Negative b, or opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. You can be used to solve any quadratic formula or quadratic equation that is written in that form. You have to have it written in that form to do it, which means you have to have 0 on one side and written in descending order according to the exponent on the variable, okay? So, in other words, standard form. All right, so in order to solve this, it's pretty straightforward. This is A, this is B, and this is C, right? So I'm going to say negative. So B is negative 4. So negative, or the opposite of negative 4, plus or minus the square root of negative 4 squared minus 4 times A is 3 and C is 1. And that's all over 2 times 3. All right, so I get 4 plus or minus, I get 16 minus 12 all over 6. Okay, so what do we get? This is two different problems, remember? So we have 4 plus 2 divided by 6, or 4 minus 2 divided by 6. So 6 over 6, or 2 over 6. What do we get? An answer of 1, or 1/3. Right, x is equal to 1 or 1/3. Okay, so that's pretty, I mean, you guys have been doing that. You've done it quite a bit. You guys did it last year. I think you guys have learned the quadratic formula multiple times. Hopefully it's sunk in, okay? All right, and then on 32 and 33, we're talking about the falling object model. This is falling. And the thrown object model, this is thrown. Okay? And for both of them, it's really straightforward as far as this is h is your final height. Many times, h, when you reach the ground after falling off of something, when the object reaches the ground, h is 0 feet, right? S up here, and actually here's h and s is over here as well. This is the initial height. This is the height that something is falling or being thrown off of. It's a starting height. Who knows? It just depends on where you're starting at in the problem, but it's usually so many feet up in the air on a diving board, on a cliff, or in a off of a building. Okay. The only difference between the falling and thrown model is the middle term, VT, and V is an initial or a starting velocity when something is thrown up or down. If it's thrown up in the air, let's see, up, then V is positive. If something is thrown downwards with an initial velocity, V is negative. Okay, so be careful of those things. You guys have done a few of these problems, if, doing the homework, so there's one of each in there. 32 is a falling object, 33 is a thrown object. So if there's any questions, please get a hold of me. You have 2 days to get this assignment done, today and tomorrow, and we will go ahead and take it from there. Good luck. Please don't hesitate to ask questions. Thank you.